Okay, so now we're going to see, like now that we know how to write equations, we're going to see what we can do with them. All right, we're going to actually use equations to solve problems, to solve word problems. So here are my steps. If you are watching this as a recording, you will want to pause the video so you have time to write all these down. All right, but the first thing is you're going to write an equation to represent the relationship. That's exactly what we just finished doing. Okay. Now you may have to figure out what is the best variable to use, okay, so that you can represent the actual quantities in the problem. So you shouldn't be using X and Y for everything, okay? And then of course don't forget you have to put the K in there. So that's the part that we've already practiced. All right, the next part is that you're going to be given some information, some numbers, and you're going to plug those numbers in to help you find K, because K is a number. All right. Then you're going to rewrite the original equation with that K plugged in. You'll see what I'm talking about in a minute. And then you're going to use that equation and any other information to solve for whatever they're asking you to solve for. Okay. And then of course, because these are word problems, your final answer will need to have some sort of units on it. Okay. All right. So here we go. First problem says the number of aluminum cans used each year varies directly. All right, so I see the word varies directly, so I'm going to kind of have that jump out at me as the number, typo, of people using the cans. All right, so before I get to any numbers, before I get to the next sentence, I need to write an equation that represents that relationship. Okay, so what am I talking about before the word varies directly? Well, I'm talking about the number of aluminum cans. Okay, so I guess I could use n for number, but you just have to make sure that you don't use the same variable for something else. And n doesn't really help me remember that I'm talking about aluminum cans. So maybe you want to use C for cans. Okay, you get to decide. All right, so the number of cans varies directly. So I'm going to set up my equation C equals K. And then directly means I'm going to multiply by something. And I have it varies directly as the number of people using the cans. So I decided to use C for cans and P for people. Okay, that's completely up to you. All right, so then I'm going to finish my equation. C equals KP. Cans varies directly with people. Cut all that extra stuff out. Okay, that is the first step from up above. Okay, now the second step is that we're actually going to find K, but we're going to find it by plugging in the first set of information given. That means what information is given together. So it says 250 people use 60,000 cans per year. So those two things are happening at the same time. So that is my set, right, of given information. That's my first set. So what I'm going to do is I'm going to make sure you know what your letters represent. I'm going to plug in 60,000 for the cans, for the C, and I'm going to plug in 250 for the P, for people. You with me? And now the only thing I'm missing is K, but I can solve a math problem to figure out what K is equal to. Okay, and so that means how do I get K by itself? And I'm going to divide by 250. Okay. All right, now I know not all of you have a calculator right next to you, so I will tell you that 60,000 divided by 250 is 240. Okay, so that is the second step. All right, well then the third step says to rewrite the original with your new K value plugged in, nothing else. So C equals 240P. Don't change anything else. All right, so now that equation can be used to solve any question. Okay? And so then that's part 4, is to actually answer whatever your question is. Use your equation and the rest of the information given to solve the problem. Okay, so the problem says, let me get a different color here. All right, predict the number of cans used each year in a city with a population of 850,000. So it's basically asking me to find the number of cans when I know a new population. Are you with me? So they want me to find C when I know that the population is 850,000. So I'm plugging in the other piece of information that I was given, and then I should be finding C for the answer. Okay? And again, I know that you guys don't all have a calculator sitting around handy, and so when I multiply the, whoop, I did that wrong. I transposed my numbers. Okay, I have 204 million, and these are cans. Okay, so let's kind of run through that one more time. So what you need to do is you need to read the problem, and you need to try to create an equation that represents just the relationship. Don't worry about numbers yet. Then you should look for a pair or a set of information that goes together and plug that in, and that will help you find K. Then you need to take the time to rewrite the original equation with just the K plugged in, because then you get to use that equation to answer whatever the final question is. Okay? Any questions? All right, let's try another one. All right, the time required to drive a fixed distance varies inversely with the speed you drive. So we're going to need to set up an inverse variation, and we have to relate the time required to drive the distance and the speed we drive. All right, so in the chat box, get you guys to interact a little bit. What variables do you want to use? I have decided to use T for time and S for speed. And those of you that answered me in the chat box, thank you very much. So the first thing we have to do is write a generic equation that puts time varies inversely with speed. T varies inversely with speed. Be careful when you use an S, okay, that it doesn't start to look like a 5, just so you can stay organized. All right, then the second part says find your pair of information, so we have to read on. It takes 5 hours at 80 kilometers per hour to drive a fixed distance. So that's our pair of information. Time is 5 hours, speed is 80 kilometers per hour. And to get K by itself, think about the math that would require. You would need to multiply the 80 to the other side. Okay? And that's going to give you 400. So that's step 2. Step 3 is to literally rewrite the original equation with K plugged in, nothing else. Then step 4 is to answer the question, which we haven't even read yet. It says, how long will it take? So that means I'm looking for a time. How long will it take, time, to drive the same fixed distance at 60 kilometers per hour? And so remember, that's an S on the bottom, and that's my speed. Okay. All right, and so then I just need to figure out what is 400 divided by 60. And guys, that does not come out super nice. So we're going to round, because it doesn't make sense to change time back into a fraction. All right, and then that would be in hours. Okay, because my other time was in hours, so this time needs to be in hours. Now, with word problems, you should always ask yourself if the answer makes sense. For example, like it took me 5 hours at 80 kilometers per hour. Well, if I drive a slower speed, shouldn't it take me longer to get there? All right, so you do always want to look to see if your answers make sense. Okay. All right, next problem. When a constant force is applied to an object, the acceleration of the object varies inversely with its mass. And that's the whole sentence. So we have an inverse variation. And let's see. Sometimes you can leave out those prepositional phrases. I know I'm not an English teacher, but the whole when a constant force is applied, that's just a lot of, I mean, you don't need that because we're more worried about what varies inversely with what. So we have acceleration of the object varies inversely with the mass. All right, so make sure that you can pick out those key components. And inverse, again, is another division problem. All right, then it goes on to say when a certain constant force acts upon an object with mass 5 kilograms, the acceleration is 10 meters per second squared. All right, well, you just need to make sure you plug those in the right places. The mass, that's your M, is 5. Acceleration is 10, that's your A. So make sure you're plugging them in the right place. Remember, the whole point is to find K before you do anything else. And so here you should get K equals 50. All right. Then you're going to go back. You're going to rewrite your original relationship equation with only K plugged in. Then you're going to use it to answer the rest of the problem. When the same force acts upon the object, its acceleration is 25 meters per second squared. What is the mass? All right, well, this one's a little bit different, folks. This time they told me the acceleration and they want to know the mass. But we have algebra skills that can help us solve for M, right? We have to get M off the bottom first. So we're going to multiply. And then once it's no longer on the bottom, we can figure out how to get it by itself. All right, and that's going to require us to divide. And so M ends up equaling 2. And then what you really want to do for your units is go back into the problem and see what mass was originally, like if you were given a mass, what was it measured in? And so this would be kilograms. All right, and for our last problem, I'm going to slide it up here on the screen. And I'm going to pause my recording and give you a chance to read it and try to solve the entire problem. All right, let's run through this last one. So so that we can then talk about what your homework is going to be. Okay, so it says Ohm's law, that's a real law, states that resistance is directly proportional to the voltage and inversely proportional to current in a simple electric current. All right, so I'm looking at what comes before directly proportional, and it says resistance, so I did R. Directly proportional to voltage, so I did V, and inversely proportional to current, so I did C. I think in the real formula it's an I for current, which I think is weird. But if any of my electricity folks, if any of you guys have taken electricity, I think it's an I. All right, so here we go. Resistance is directly proportional to voltage. So you should have K times V, and then inversely proportional to current divided by C. Are we good with that? How'd y'all do on that? Good. Okay. Then we read on. One circuit has a resistance of 8 ohms when the voltage is 48 volts and the current is 6 amps. So they're saying all of those things happen at the same time. So that is my set that I plug in at the same time. All right, so let's see. Resistance is 8, voltage is 48, and current is 6. Okay, now there's a couple of different ways to solve this, because remember, you've got to find K. You can do it in a couple steps. Right, maybe you multiply by 6 first, right, and so then you get 48 equals K times 48, and so then you divide by 48, and did you guys get K equals 1? Okay, so once you have that, remember, you go back to the original equation and you plug in that 1 in place of K and leave everything else letters. And of course, if it's a 1, you don't even have to write it. And then you answer the question, what is the resistance? So they want you to find R, right, of a second circuit that has a voltage of 128 volts and a current of 8 amps. All right, and so then you just do 1 times 128 divided by 8. All right, anybody want to type their answer in real quick? 128 divided by 8. Good. Anybody else? Give you a quick second. Oh, yes. Thank you, guys. Yay. Okay. You got 16. Very good. Awesome. Yay, 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 yay. Okay. All right. And so then the last thing is to figure out what the units are going to be, because it's a word problem. So the best way to do that is to go back and look at what the units were on the resistance that was given earlier in the problem. Remember, it was 8 ohms. The Ohm's law is named after a man, all right, with last name Ohms, and so those are going to be my units. Okay? Any questions?